Here is an explanation for the answer to final exam question number 61 in Physics Demystified, 2nd edition. If you have the printed book, you'll find this on page 527. We have a rocket ship here, a pretty light rocket ship, 200 kilograms is its mass. That's only about the mass of 3 full-grown people, so it's obviously not a ship that carries people. It's probably a robot ship. Imagine that the engine of this ship imposes a force of 4,000 newtons, a force vector of 4,000 newtons in the direction of Betelgeuse, a star in the constellation Orion. We want to know what the acceleration vector A is. Now I've used little half arrows over the letters here to indicate vectors. In the book, they're boldface instead. You will find this formula on page 74. It's very simple. If we know everything in standard international units now, mass is in kilograms, the Newton is a standard international unit of force derived from meter, kilogram, and second. So we're fine with this formula. We'll get the acceleration in meters per second squared. Well, let's revert just to the magnitude, because we know that this vector is going to go in the same direction as the force, in a straight line, presumably, toward Betelgeuse. We know it's toward that star, so it's going to be either B, Bravo, or D, Delta. Our answer will be either B as in Bravo or D as in Delta. Well, let's just work that out. Force, magnitude 4,000 equals the mass 200 times the magnitude of the acceleration. It's easy enough to do this. When we work that out, we get A equals, and that's the magnitude is written without a little arrow or in italics to indicate that we're just talking about the magnitude of the vector here. We already know the direction. 20.0 meters per second squared. I don't think there's room on the beige board here. Well, maybe there is. Meters per second squared in the direction of Betelgeuse. That's choice D.